Hello everyone. In this session I will discuss about genetic algorithms with an application. In last session I told you about what is a genetic algorithm. Let us recall just a small recall. Genetic algorithms are a family of optimization searching algorithms, specifically local searching algorithms that give solution to a problem through natural process of evaluation. Like they give like analogy of natural process evaluation is applied while giving solution or optimizing a AI problem. And I told you several steps involved in this algorithm. So genetic algorithms, the first step is you have to take the population. From the population we collect the samples. On those samples we find the fittest score. Like in our example AI optimization, we find the set of sample solutions. Using the fit function we calculate the fit score. Based on the fit score we select the parents. After selection of parents we perform crossover. Crossover gives the offsprings. We mutate the offsprings for our making it more efficient. And when offsprings generation is similar to parents continuously, we stop the generation. The same analogy now we apply in optimizing AI problems. How we do it? Let us discuss with a small problem. Let us have one function f of x equal to x square. Here my problem is optimize this problem. I have to maximize the function. Maximizing means for a given input I have to find out what is the largest value this function can give as a output. So my x is permitted between 0 to 31. What are the samples that can give the best maximized value? Here I am optimizing the function. I am optimizing the samples that can generate largest value. Now how? First step in genetic algorithm, selecting encoding technique. See, my function takes inputs between 0 to 31. So I represent each number in some binary number encoding. I am using a binary encoding technique where each number is converted into 5-bit binary number. Suppose 0, 0, 0 represents 0, 31 represents 31. So first step in genetic algorithm is selection of initial population. Now here I have taken 4 input numbers like 12, 25, 5, 15. Whether this solution on these 4 values, now I take this population. Each number is converted into corresponding binary number of 5-bit length. When you convert 12 you get this binary number, 25 you get this binary number. Now I use a binary bit encoding and applied encoding on my population. Now what we take, this initial population that I randomly selected. Now whether these numbers are can be selected as parents or not, whether they can be performed as a crossover, can we perform on them? Let us we have to evaluate using a fitness function. We find the fitness of each sample, whether it is fit for parent or not. Now 0, 1, 1, 0, 0 is now we say that 12. Now I calculate a square f of x equal to x square means 12 square 144, 25 625, 525, like this I made this one. Then I find the probability of selection of this sample as a parent. So how I do this probability of selection? Now so I say Pi equal to Fi into sum of Fi I equal to 1 to n. Here I have a population of 4 only, I calculate for 1 to I. What is the sum here? 1155. What is the value here? 144. I say a probability of selection of this sample is like 144 divided by 1155, sum of the numbers. So I get 0.1247 as my probability. Like this for every sample in my population, I calculate this one. Means here I am nothing but these are solutions, whether these can be taken as inputs or not, solutions. Now similarly for 25 I got these probability values, probability of checking whether they are fit for parents or not. Next, percentage of converted into percentage. Then I made this expected count. We calculated probability as for each sample as its square divided by sum of the all samples, fitness of all the samples. Now next we calculated expected count. Expected count is nothing but n into, here n means total number of populations that I have taken 4 into your probability. What is the probability now? 4 into 0.1247. Here you get 4987. Like this we calculate expected count for each sample. Then we round off it to the actual count. It is nearby 1, this is nearby 2, it is 0, means we negligible only, this is 1. Like this we count the actual count. The actual count gives us the who are the strong, who can be a strong parent in these 4 samples. Now see, a third sample I got a count as a 0, that means this is not fit for a parent to cross over. So I take 1, 2, 1 and highest point is there, second one has a highest value of count. This is like a human actual count tells the strength of our, whether they are able to reproduce or not. Now this is second step in genetic algorithm, evaluation of fitness. Now next step, now parent selection is done. We have the only these 3 parent samples are eligible for becoming a parent, but third one is 0. So in place of third one, who is the strongest parent, I replaced. So this is a step of crossover. Here in crossover I prepare a table, mating pool, crossover point, offspring crossover, x value, f of x square. Now I made these, I selected these 4 as my final sample of who has eligible for becoming some parents type. Here parent nothing but eligible solutions, that can be eligible solutions for my problem. Now I select randomly, I set one crossover point. Suppose I set as a crossover point as 4. That means up to this one crossover point. So here they are like, you know, from this point you concatenate with this one and you concatenate this one. Like 4 point, when you cross over you get like 0 0 1 0 is concatenated with 1, 1 1 0 is concatenated with 2. Like this I took 2 random crossover points. First 2 I crossed with 4 level, second 2 I crossed with that 2. 2 means second becomes the second point of crossover. From here I concatenate with this one, this part I concatenate with 0 0 1. Like this I made a offsprings. After crossover I prepared a offsprings. Then I converted these offsprings, means the next generation parent. I selected a strong parents based on their count. I selected their fittest or not. Then using their those parents I crossed and I prepared offspring, new offsprings. Those offsprings, if you convert again into x, these are the new solutions for my function. They can make a maximize my function, optimize my function. So again 13 into converted, these are my new values. See here I maximized it. Initially it was in before crossover of their parents. Okay, this is new one, sum is 1763. Now what we do, again we apply mutation, means offsprings are mutated to make them more efficient. Here offspring after crossover, mutation chromosome for flipping, means I told you chromosome is a combination of genes. Here gene is either 0 or 1. This chromosome I prepared as 1, and when you apply a mutation, this 1 position flipped with this 0 is first position is 1, that means this position is flipped with 1. So you get 1 1 1 0 1 answer. Similarly here all are 0 means there is no mutation because they are already strong parents. Already strong parents means you don't need to again mutate them. So but there are, I flipped this one, I made it a strong with a chromosome combination 0 0 means at the third position 0 will be flipped to 1. This last position 1 will be flipped to 0. Like this I created a new offsprings after mutation. Previous there is no mutation, just offsprings are created. I applied mutations, like this is also happens in humans. Suppose some rare conditions, some mutations happen in the genes of a human and generate new diseases. Similar also we apply mutation of this one. After applying mutations, these are new generated x values and their x square values. If you sum, my value become maximized, means I optimized my function. Like this so that means you can take these solutions as the strongest points that are that can maximize my function. This sample will give as a solution. That means I optimized my problem of maximizing using genetic algorithm. Like this we have to follow the steps of selection of the samples. Here the selection of the solutions, fittest of the solutions, crossover of the solutions, offspring of the finding offsprings, mutating the offsprings, and finally finding actual optimized solution. So how this is how a genetic algorithms works. Thank you.